Okay, this is our next problem, and I coined this problem the horizon problem. You'll see why. So it says the CN Tower in Toronto, Canada has an observation deck 447 meters above ground. I've actually been in the CN Tower. I think it looks more like a Space Needle kind of thing, like the one in Seattle. So maybe you've been there too. About how far to the nearest tenth of a kilometer is it from the observation deck to the horizon? And now you can see why I call it the horizon problem, because it involves the word horizon. Earth's radius is about 6,400 kilometers. Now I've given this picture, right? This is the Earth, okay? The CN Tower is this thing right here. That's the CN Tower. So I am standing at the top of the CN Tower and I'm looking out this way. This represents the horizon. So that segment is the horizon. And the question is, how far can I look out to the horizon? Again, notice that, the Earth is round, right? So when you see that horizon line, it's really the Earth dropping off, right? Because it's turning. So be aware of that. All right, so this is what everything means. So let me take that away and put the numbers on there, okay? So we are 447 meters above the ground. So this distance right here is 447, and I'm going to put meters, and I'll talk about why. So about how far to the nearest tenth of a kilometer? So be aware of that. So right now in my head, I'm thinking 1,000 meters is equal to 1 kilometer, right? Kilo means 1,000, so be aware of that. Is it from the observation deck to the horizon? So how far is this called this x? And they say the Earth's radius is about 6,400 kilometers. So in this picture, there's actually two radii. That's a radius, and that's a radius to this point. So both of those are 6,400 kilometers and 6,400 kilometers. Okay. All right, so two things. Number one, how are we supposed to do this problem? Well, I have a tangent. The horizon line is tangent to the Earth. So this is my tangent. And here's a radius intersecting a tangent. This angle is going to be a right angle. And now I can use Pythagorean Theorem. I have one side that is 6,400 kilometers. I have one side that is going to be x kilometers. And now I need to know, what is the length of this side? What would this be combined? Well, first of all, I have to combine my units, or make my units the same. One is in meters, one's in kilometers. So 447 meters is how many kilometers? Well, the way that we do that is we take the 447 and we divide by the 1,000 meters. When we divide by 1,000, we're changing that into kilometers, okay? So when you do that, you're going to get 0.447 kilometers. That's how many kilometers 447 meters is. So now we're just going to add that to the 6,400 kilometers. So add that to 6,400, and you're going to get 6,400.447 kilometers. That'll be that length of that right triangle right there. Okay. So again, I'm sorry for the units and the fact that they're weird, but it is what it is. Got to keep the units straight. And now this is just a Pythagorean theorem question. To use Pythagorean theorem, we do a squared plus b squared equals c squared. A and B are your legs. Let's let x be A and this radius be B. C will be this third side. So C is going to be that number 6,400.447. So we have x squared plus 6,400 squared equals 6,400.447 squared. Now, just as a little trick to avoid writing down a bunch of numbers, we need to get x by itself. So let's get x squared by itself. Before we square these numbers individually, let's just subtract the 6,400 squared. That's going to get x squared by itself. And I'm going to type this in. Let me change colors real fast to red. I'm going to type this in exactly as it looks, and you'll see me. I'm not going to do the subtraction first. I'm going to type that in exactly as it looks. So watch what happens. So it was 6,400.447 squared minus 6,400 squared. Now, a lot of people want to do this. Watch. They want to do the 6,400.447 minus this. They want to do that first. They want to subtract first and then square that. Notice you don't get the same thing. Not even close to the same thing. So do not do it this way, right? Do not try to subtract the numbers first and then square. You must do it just as this is. And again, it's just to save some writing. So this is what x squared equals. X squared equals that. So now to get x by itself, I need to take the square root. And I'm going to take the square root of this number. So I believe what I can do, so I just type in square root, and I'll do 5721.79989. And there I go. And I believe it said to the nearest tenth. Let's go back and look real fast. To the nearest tenth of a kilometer. And because we did all the legwork up front, this is in kilometers. The 6 is in the tenths place. The 4 does nothing to the 6. So this is 75.6, and that would be kilometers. 75.6 kilometers. That's how far out we can see from that observation deck. So in that problem here, 75.6, and don't forget to choose the correct units. That would be kilometers. Kilometers. There we go. Okay. So again, just a Pythagorean theorem application. All right, next problem coming. Okay, now this says find the value of x to the nearest tenth. Okay, so if you take a look at this picture, right, they kind of give you a hint because they put the right angle in its place. 10 is going to be the tangent. X is your radius. Notice it's on there twice. That's also radius. But where the tangent and radius meet, that's a right angle. That's perpendicular. So this is a right triangle, and we can use Pythagorean theorem to try to find x. Now, the catch is this. Your hypotenuse. Part of it is x. Part of it is 6. A lot of people want to say that that is 6x, and that is wrong. This is segment addition. You're taking x and you're adding it to 6. Unfortunately, it doesn't change. It just becomes x plus 6. And we're going to put that in parentheses because that's called a binomial. So please do not make that 6x. It's not multiplication. It's addition. Okay, and now we use Pythagorean theorem. A squared plus b squared equals c squared. A and b do not matter. I'll let x be a and 10 be b. The hypotenuse across from the right angle is c. So x plus 6 is your c. So x squared plus 10 squared equals, and this is x plus 6 squared. Now you have to be very careful here, right? The left side's pretty simple. The x squared doesn't change. 10 squared, you just type it in your calculator or you know it, it's 100. But now how do we do this x plus 6 squared? Well, a lot of people want to do this. They want to do x squared plus 6 squared, which would be x squared plus 36. That again is wrong. You are not allowed to distribute the squared. What you should do is you should write x plus 6 twice like this. And now you need to distribute this out. This x goes to the x and 6 of the other parenthesis. X times x is x squared. X times 6 is positive 6x. And then this first 6 in the first parenthesis goes to the x and the 6 in the second parenthesis. 6 times x is 6x. And 6 times 6 is not 12, which a lot of people want to do. 6 times 6 is 36. And then you do combine the middle term to get 12x, and that is what goes underneath the x plus 6 squared. X squared plus 12x plus 36. So again, if you do it this way, right, you miss that important middle term. So don't do it that top way. Rewrite it twice and multiply it out. And now you're saying, oh no, I see x squared on both sides. This is a quadratic, right? Maybe you know what that means. Well, it's okay, right? Because this is a positive x squared. That's a positive x squared. They're going to cancel because you would have to move everything to one side. And if you subtract x squared from both sides, they cancel. So they're gone. So now your problem is a simple two-step equation. 100 equals 12x plus 36. If you don't do it that way, it's not going to work out. And now we just solve this for x by subtracting 36. That's 64 equals 12x, the 36 cancel, and divide by 12. And I'll do 64 divided by 12. It says round to the nearest tenth. So for my value of x, I get 5.33. The second 3 leaves the first 3 alone, 5.3. And that's no units in the problem, so that's all. And that's your value of x, 5.3. So this is drawing back to your Algebra 1 days. All right, last problem coming. Okay, so it says circle O is inscribed in triangle PQR. So what does that mean if it's inscribed? That means that it's going to be tangent to all three sides. So X is a point of tangency, Y is a point of tangency, Z is a point of tangency. So be aware of that. Now it tells us that this triangle has a perimeter of 88 centimeters. Remember, perimeter is the sum of all the sides. What is the length of QY? I'm going to call that X, right? Lowercase x. Well, this problem has to do with that two tangents theorem. You have three exterior points, P, Q, and R. These 3 points are going to be endpoints of tangents. Those tangent segments that have the same endpoint are going to be congruent. So if Q to Y is X, Q to Y must be the same as Q to X over here. So that's also going to be X because they're congruent. If R to Z is 17, then that means R to Y must also be 17. And if P to X is 15, then P to Z must also be 15. And now I think you have every part of the triangle's perimeter taken care of. So to find the perimeter of the triangle, we're going to add everything up. Now notice that there are two 15s, two 17s, and two X's. So 2X plus two 15s plus two 17s. Whatever that equals is going to equal the perimeter of 88. So 2x plus, and I would just type in 2 times 15 plus 2 times 17. That's 64. So this all comes out to be 64. That should equal 88. And now it's a simple solve for x by subtracting 64 from both sides. 2x equals, the 64 cancels, this is 24, and then divide by 2, and x is 12. And that is the length of QY. QY is 12, it is in centimeters, so we will add that centimeters, 12 centimeters. Okay. So again, tangent lines. A lot of Pythagorean theorem going on because of that first theorem. All right, best of luck. If you have questions, let me know.